Yeah, okay. So welcome everyone. This talk is about account abstraction on EVM-compatible networks. In particular, I'll be looking at Hedera as well as Ethereum. And yeah, just by way of introduction, for those of you who've been around and for a while, like I did dApps Dev Club, when was that, 2019? And then I've been at Rootstock for 4 years, and I've recently moved over to Hedera, right? So I've been doing, I guess to summarize it, doing Web 2 software engineering, and then now Web 3 DevRel. So yeah, if you want to read about the stuff I've been writing, you can check out my blog that's been in the footer, bigwiz.com. All right, cool, introductions over. Okay, so here are the things that we're going to cover today, right? We're going to talk about the basic concepts of DLTs, specifically the ones that are related to accounts, right? And then we'll talk about Hedera's specific take on these concepts. And then we'll have a couple of demos, or at least that was what I originally planned. But in light of time, I'm going to cut that down and just do a code walkthrough instead. Excuse me. All right, so the main focus of the demos, or the code walkthroughs, I should say, are about how to use cryptographic keys as well as smart contract invocation flows, right, to authorize transaction execution. And then finally, we'll cover the main topic, which is what is the process of enabling account abstraction on an EVM-compatible network, and like some sort of now and in the future sort of thing. All right. Okay, so before we start, just introducing what Hedera is. For those of you who have heard of Hashgraph but not of Hedera, it's kind of the same thing. Hashgraph is the consensus algorithm that was invented first, and it was invented without necessarily having a blockchain attached to it. And in fact, one of the first ideas around Hashgraph was to create a database layer that was nothing to do with crypto at all. But then eventually they went down the route of creating a blockchain-like thing, and then that became Hedera. So, okay, so if you see Hashgraph, for example, our GitHub repo is github.com/hashgraph. That's the GitHub org. It still is like that for historical reasons, but yeah, the main network name is Hedera now. All right, so let's start about talking about some fundamental stuff. So if you come from some Bitcoin or Ethereum context, right, what is a private key? It really is just a really large number that's been randomly generated, so you have sufficient entropy, right? And then you use an elliptic curve, right, one specific one, SECP256K1, which you use to just find the matching thing that is your public key, right? So there's just a quick lookup on the elliptic curve. So that's like asymmetric keys, right? And then the next concept is accounts, right? And how do you get an account? So you get a private key, use the elliptic curve, you get a public key, and then from there you create an address. And what is an account? It really is a set that combines all of these three things, right? Private key, public key, and address. Now, what is interesting is that these that there is like a one-to-one context, one-to-one relationship between an account and its private key, and what that basically poses a problem for account abstraction, because when you have when you have that one-to-one relationship and it's kind of baked into how the implementation is done, then it creates it prevents account abstraction from happening, right? Because that private key always corresponds to the public key, and there's no two ways about it. So that's kind of the crux of what we'll be talking about today, right? So now let's, Hedera is EVM compatible, right? And that was actually the thing I talked about in my previous talk in SoliditySingapore, like about 3 months ago. So since then, I have learned that Hedera's account system, I'm new at Hedera, by the way, so I've been only there for 5-6 months now. So I've since learned, right, on job, that actually Hedera's account system isn't the same, despite being EVM compatible as Ethereum or any other EVM compatible network that I know of, right? So in Ethereum, you only have these ECDSA keys, whereas Hedera has that, and it also has EDSA keys, a different elliptic curve, but they're not exactly compatible, even though they're conceptually quite similar. And then the other thing is that in Ethereum or EVM-compatible networks in general, you have an account which can only have a single key, whereas in Hedera you can have that, or you can have what we call a threshold key or a key list, and what those basically enable is multi-sig or M of n multi-sig, right? Yeah, so that is not something that you need to do with a smart contract, which you happen to need to do in other EVM networks. You can just use that off the bat because Hedera is set up with that from the get-go. No smart contract necessary to achieve multi-sig, right? The other thing that is important to point out is that when you create an account with Hedera, you have an initial private key, and you can say, okay, I don't like this anymore. I'm going to switch it to a different private key or a different complex key that consists of new private keys. So you have all of these options, right? And now coming back to what I mentioned in the previous slide about decoupling keys from the accounts, right? So this concept is already present and it doesn't require any further implementation in Hedera. It just already has that and has had that for, I think, since, if I'm not mistaken, since inception. So like since 2017, since 2018. So it's not a new thing in Hedera. It's just been around since the get-go. All right, so I'm going to do a code walkthrough over here, right? And we're going to be doing basically a 1 or 2 multi-sig, and specifically it's going to have one EC DSA key and one ED DSA key, right? So, my QR code didn't load. All right, okay. I'll send the links in the chat or the GitHub issue right after this presentation, but otherwise you can check it out on the screen. If you go look for github.com/hedera-dev, and then you'll find a repo underneath it called Hedera code snippets, and it's inside, it's within that repo, right? Yeah, sorry about the QR codes going missing. All right, so hang on. All right, here we go. So, yeah, can everyone see that? Is the screen size big enough? Not really. Slightly bigger? Okay, let me see. Not much difference. Okay, sorry. All right, so the first thing that needs to happen is that you need to generate the keys, right? And then once you've generated the keys, and you can see here that I've done one EC DSA key and one ED DSA key. And then the next thing is I create a list that's just basically an array that consists of both of those keys and convert it to public keys. And then after that, I create a key list with comma 1 at the end, right? And that says, okay, so I've got an array of 2 keys, and then I have a threshold of 1. And so that means I've got a 1 of 2 multi-sig requirement. So that's what this is saying over here, right? Then the next thing that happens over here, right, is that I do an account update transaction, right? So you say, for this particular account, I want to set the new key, and then I sign it with the original key that the account was created with, right? So originally it only had 1 key, and then you create a transaction saying, I want to update its key to this new 1 or 2 multi-sig combination key called a threshold key. And then I execute that transaction, and then if that transaction is successful, then from then on, you can use the multi-sig key on this particular account, right? All right, so the next thing here is just basically this is where the demo would have come in handy, right? So this is a transfer transaction. You can say, I'm gonna do something on the account that requires it to be signed. And then instead of signing it with the original key, I sign it with one of the new keys, since it's 1 or 2. And then if it succeeds, then you know that the transfer transaction has succeeded. Right, so we don't have time to actually do that demo today, so I encourage you to go to the GitHub repo. I'll send a link later, and you can try it out for yourself. All right, let's move on quickly to account abstraction, EIP. So Ethereum has several EIPs which aim to enable account abstraction. They're listed on the screen there, and so I'll be the first to admit that I'm probably less well versed in it than most of you are here. So please educate me after this talk or something if I get everything completely wrong. But let's go very briefly over I guess the core ideas in these EIPs, and then use them as a starting point, and then I'll just bridge over to Hedera, right? So yeah, so first of all, we have 2771, right? This proposes no changes to the underlying Ethereum protocol, and it proposes meta transactions, and the goal is to have one account pay for the gas of another account. And my comment here is that Hedera already has this concept, right? You can have a signer account and a payer account, and it's been built in from the get-go, right? It doesn't need to be added, or the implementation doesn't need to be changed, right? So it kind of already has that. This is probably the most well-known one for 337 for account abstraction, right? So it also, similar to the previous one, has a goal of avoiding protocol level changes in Ethereum. And it basically, its main thing that it proposes is that it'll enable building something it calls a smart wallet, right? Which is the ability for a smart contract to essentially transact on your behalf, given that you have somehow, I guess, whitelisted it or given it permission to do so in advance, right? Next up, we have 2938. This has the goal of introducing a new transaction type, but then it also stays away from changing consensus rules. So it's kind of like a partial change to the protocol, but not a full change, so to speak, right? And then it says, okay, this new transaction type is specifically for operations that are needed for account abstraction. And then finally, out of the four, we have 3074. This is the only one out of all of them that I've highlighted here that actually proposes a change to the Ethereum protocol, a full change, and it does so by adding two new opcodes, which you see on the screen, and these enable an EOA, an externally owned account, to authorize a smart contract to act on its behalf. So that's kind of similar to 4337 in some ways, but the implementation, the way it's implemented is that it proposes is different. So now the core idea behind EOAs, as they are on Ethereum right now, is that they maintain a one-to-one mapping between an account and its keys. So those are tightly coupled, right? And because it's inseparable, right, it makes it hard to do things where the account wishes to delegate or somehow in other way allow something else to act on its behalf, such as a smart contract. And that smart contract might be a smart wallet, for example, right? So the core, I guess, problem that needs to be solved is decoupling those two things, right? So maybe one or more of these EIPs will succeed in doing so eventually, and Ethereum will attain that goal of account abstraction. But of course, these things take time and they need a lot of discussion and deliberation. So we don't know whether it'll come in this format in one of these EIPs, or we'll see something else, or yeah, we'll see how that pans out, right? So now, as promised earlier, let's come back to Hedera, right? And how it kind of relates to these EIPs. How do they fit together? So one thing I mentioned is that Hedera accounts they've already broken that barrier of being separate, of decoupling accounts from the keys the private keys that are able to control them. So you can change them, you can have multiple ones, etc. Right? So I've already mentioned that, but let's take a look at it through the lens of these four EIPs that I just mentioned. So 2771, right, allows for one account to pay for the transaction fees of another account. And as I mentioned earlier on, Hedera has a payer account and a signer account, and those can be two separate things. In fact, fun fact, every time you connect to Hedera over JSON RPC, that's precisely what's happening, right? The JSON RPC can actually sign the payment on your behalf if you've configured it to do so, right? Right, so its transaction model is different because of the separation, right? Now, 2938, right, approximates to transactions having additional fields, right? And Hedera has additional fields, right? Because it needs to support more than one signature, for example, and several other things, right? So it already has this kind of thing built in. Now, finally, you have, 3047 and 4337. Both of these EIPs are about saying, hey, here's a transaction, and I allow the authorization of that transaction to be transferred or delegated from my EOA to something else, maybe another EOA, maybe another account, right? Hedera also partially supports this right now, and I'll emphasize partially, right? Because it allows accounts to define these complex keys, such as threshold keys, and what's the other one? Key lists, right? Which are effectively multi-sigs. And one thing I didn't mention earlier on is that those complex keys, you can have ECDSA keys, and you can have EDDSA keys, and you can also have a smart contract ID as part of it. So that's the third thing that could that a complex key in an account can control, right? And that's where the smart wallet concept comes in as well, or could come in, right? So now that I've mentioned all of these things that Hedera already has, right? Here's the big question, right? So does Hedera already have account abstraction? And my answer to that is it's pretty close, but not yet, right? And I have to go and sort of take a sidebar and explain this concept called system contracts, which is something that Hedera has, right? So they behave like some regular smart contracts. They have an address. You can interface with them through an ABI, but they never have been implemented using Solidity, right? So it doesn't execute within the EVM. Instead, it's directly implemented within the Hedera node's code itself, right? So this is kind of similar to if you have compiled a language in Java and then called a C library and you use an FFI, it's basically the same concept, right? But on-chain version of it. So when working with Hedera system contracts, you can think of the ABIs in that manner, right? So coming back to what's on the slide, smart contract-based authorization is restricted to authorizing presently system contract invocations only, right? So only this category of smart contract system contracts may be authorized via when you have an account where one of its constituent parts of its complex key is a smart contract ID, right? But if the target of the smart contract execution is a custom smart contract, then that's a no-go presently, right? So it seems like this is the last piece of the puzzle. Like if that is present, it sounds like we have account abstraction, right? But then I'm sure any of you who's done like software engineering in a large project before in multi-years kind of thing, it's like, okay, we've completed the first 90%. Now it's time to do the last 90%, right? So I'm sure a few of you have heard that before, right? So it kind of feels like that. Okay, so let's do another demo, right? Or I should say code walkthrough to show how this smart contract-based authorization flow works, right? And we will use a pre-compiled, not pre-compiled, system contract, right? Oh, I should mention that system contracts are kind of similar to pre-compiles in Ethereum, right? So like EC recover, that's a pre-compile, yeah. So imagine if that was actually a full smart contract in itself. Okay, so in this demo, which is just a code walkthrough, we'll have a complex key which includes a smart contract ID, right? And it will interact with one of the system contracts, but the one that is interesting to us, right, and the one that we will actually interact with is something called Hedera token service, right? So this sidebar again allows you to create and operate fungible and non-fungible tokens, similar to ERC20s and 721s, without actually writing or deploying any smart contract. So it's just like a native API. So it's separate from the smart contract system, but interoperable with the smart contract system via this system contract, right? And that's a completely different topic. I don't want to go into that, but what is relevant is that you can, okay, yeah, so you can send tokens around by interacting with the system contract. And this is actually pretty relevant because what do smart wallets want to do? They want to send tokens around on behalf of an account, right? And that's one of the key goals of account abstraction, right? So let's skip that. Okay. So it's at the same repo. Sorry about the QR code. So what's happening here? This is a Solidity smart contract. So Raman, tick that box. All right. All it does really is initialize the system contract, which is available at this hard-coded address, and then we're calling a transfer token. That's all it does, right? So what's interesting is that I'm going to call this function without signing the transaction, right? So there's going to be no ECDSA key or EDDSA signing a transaction to call this, and then let's see how it works, right? So the first thing is after deployment, I'll say, okay, here's the smart contract ID. Then I'm going to generate an elliptic curve key, like a standard private key. Then after that, I will create, this is similar to the process that you saw in the first code walkthrough. Exact same process, but instead of two different private keys, elliptic curve keys, I have one elliptic curve private key and one smart contract ID, right? And then, so then I create that account with that particular thing, right? And yeah, I update the account to use that complex key, right? So now my account has multi-sig capability, but one of the things that can operate the account on its behalf is not a key, right? It's a smart contract, the one that you just saw, right? And then this is a demonstration, right? So without using Ethers.js, you can use like a Hedera native way of interacting with smart contracts. And then you say, okay, I'm going to call that smart contract with this thing. And here's the thing, right? I execute this last line. I execute the transaction without signing it, right? And then that actually goes through, the transfer goes through, right? And it's like kind of magic. You could never do that in Ethers.js, for example, because it doesn't even have the concept of executing a transaction, right, without first signing it. So yeah, interesting things that you can do in Hedera because of its different account system. All right, so now I'm going to wrap up. Okay, so let's talk about enabling account abstraction now in the future, right? And some crystal ball predictions, right? So let's think about the various ingredients that one would need to enable account abstraction. I've covered all of them, and I think Hedera has almost everything, right? So that one last piece is the ability to do what I just showed you on general smart contract, like any user uploaded smart contract, as opposed to only system contracts. Let's see. And yeah, it also has the ability to do M of N multi-sig transactions, so that's another degree of separation. And yeah, so the idea is that once we enable this sort of multi-sig transactions where one or more of the keys can be any custom smart contract, and the target of those calls can be any custom smart contract as well, then you can do all the things that account abstraction needs to do. All right, so what's needed? So we have two HIPs, right? The first one over there has already been accepted, and it's just a matter of implementation, and I think that gets us most of the way. And then 792 is a new one that I've just raised as a result of creating this presentation, actually. And it's more of a clarification of the first one, right? So just checking the boxes, making sure that this particular use cases that are required in account abstraction can actually be enabled in the first one, right? All right. Okay, so now that we've covered those HIPs that get over the final hurdle, we'll get back to the question we asked earlier, which does that mean that Hedera will have account abstraction? And I say that this is a journey that hasn't been fully trodden by Ethereum or Hedera, right? And so therefore it really doesn't, we really don't know where it'll end up in either of the network, right? So here's my crystal ball prediction as promised, right? I think that there are a couple of conclusions, right, that I can see or I can make from what I've seen so far, right? I think firstly that both Ethereum and Hedera are going to achieve account abstraction at some point in time in the future, which is great news, right, for the ecosystem. Now, the second thing that I take away from it is that each network is probably going to achieve account abstraction in a very different way, and really the reason for that is because the EIPs that have been proposed thus far, they talk about avoiding protocol level changes, whereas within Hedera, like the community consensus is quite different, right? So that's it. And yeah, so yeah, let's see, check in again a year from now or so and see how wrong I was in those predictions. All right. So I think, yeah, I'll just leave that on the screen and, do you have any questions? Do we have time for questions? No questions. Okay. All right. Find me in the back.